Hello, this is Mrs. Taylor, and I'm going to review what we learned about graphing quadratics. So, way back before we took the benchmark, we learned about how to sketch the graph of a quadratic and then use our calculator to find these properties: y-intercepts, x-intercepts, maxima or minima, and intervals of increase and decrease. So, I'm going to review that with this video. First thing we would need to do if we're going to sketch a graph is type our equation into y equals. So negative 2x squared plus 12x minus 15. I would go to y equals, it was negative 2x squared plus 12x minus 15. If I go to the table, I can have a list of values that would allow me to plot the points I need to graph. So I'm going to plot those points. I have 0, negative 15, won't fit on my graph, so I'm not going to stress about plotting that one. 1, negative 5, 2, 1, 3, 3, and then that looks like it's my vertex because I go back down to 4, 1, and then 5, negative 5. And you'll have to forgive me, I'm using the mouse to draw this, but I'm going to try my best. Remember that your parabola needs to be U-shaped, not V-shaped. So I told y'all in class to start at the vertex and make your U. Oh, this is going to be bad. And then connect your points from there. What a terrible looking graph. Graphing by hand is hard enough, but by mouse, whew, that's hard. Okay. Anyways, all right, and we know it's going to continue downward from there, so I'm going to add those arrows. Okay, so now that we have it graphed, we can kind of identify some of these points of interest. So looking at the table, my y-intercept is where x is 0. So I can see from the table, even if I can't see from the graph, that is 0, negative 15. That's my y-intercept. So y-intercept 0, negative 15. Now my x-intercepts, if I look, don't look like they're on whole number coordinates. So I need to rely on my calculator to kind of estimate where those may be. So if I go to my graph and I press trace, I can move my cursor along the curve to get to approximately where that x-intercept is. And it looks like it's between 1.6 and 1.8. So maybe it's 1.7. So I'm going to type 1.7, press enter. Pretty close. 1.75. That's even closer. So let's go with 1.75. So our x-intercept is approximately 1.75. And then there's a second x-intercept. If you look at the graph, we have an x-intercept on this side too. So I'm going to move my cursor over there, get as close as I can. Looks like it's pretty close to 4.2, so 4.2, pretty close. So we're going to estimate that to be approximately 4.2. And remember, when we're graphing, it's always an estimate, so it's okay to be close but not completely accurate. The only way to get an exact answer is using out. So when you have a parabola, you will either have a maximum or a minimum. This parabola is opening downward, so I have a maximum. Another way I could have known that is from the a value. That's the coefficient for the x squared term. If it's negative, it will be pointing downward. The parabola will point downward. For number 2, see, we have a positive squared term, so I know that number 2's parabola will point upward. All right, so max and min, this would be a maximum. And it is going to be at my vertex, which is this point here, 3, 3. That's the highest point that that parabola reaches. All right, increase, decrease. You are thinking of your parabola in two halves. So if I split my parabola in two with an axis of symmetry, that's what you call that line that cuts a symmetric figure into two halves. And if I start on the left side and move to the right, because when you read a curve like you read a sentence. Start on the left, move to the right. So starting on the left, my first half is increasing. So the way I define that is I say, okay, any x value to the left of that axis of symmetry represents my increasing half. So to the left goes with less than. So we'd say x is less than 3. That's the half of the graph that is increasing. And then it switches when it switches from being less than to greater than. It switches to a decrease. So starting at my vertex and moving to the right, I've got a decrease. So that would be greater than 3. Alright, so doing those same steps with number 2, just to review, I went to y equals and entered my equation. So y equals, clear out what's there, x squared plus 6x plus 10. Can look at my graph. It is pointing upward like I anticipated. Go to the table, so second table. And when I look at this table, I'm not seeing that increase and then decrease that I need for my graph. So I'm going to go up a little bit to see if I can find what I need. Because when we graph a parabola, we know it's going to be U-shaped. It's a quadratic. It's got that x squared. So I need to see that pattern where my numbers go up and back down, or down and back up. So that's this part right here. And so I am going to plot those points on my graph. And so I have negative 6, 10 won't fit, so negative 5, 5 be up here. And then I have negative 4, 2, negative 3, 1, negative 2, 2, and then negative 1, 5. And once I have those points plotted, I can connect them. And again, doing this with the mouse is going to be a challenge. Hey, that looks better than the last one. All right. Okay. Oh, spoke way too soon. All right, here we go. There we go. And then I'm going to put arrows on the end because I know it continues infinitely upward. Alright, so from there I'm going to fill in my other information. So my y-intercept is where it crosses the y-axis, which is where x is 0. So x is 0 here at this coordinate 0, 10. Even though I can't see it on my graph, I know from my table that's the y-intercept. So 0, 10. The x-intercept, well, look at your graph. It goes down to y equals 1 and then goes back up. It's never going to cross the x-axis. Therefore, it cannot have an x-intercept. So we'd say does not exist. And you can have that with quadratics, just like you had it with exponentials. It may not cross the x-axis. And it would not be correct to say that the x-intercept is 0, because 0 is a number on the graph. We don't want to confuse that in math. We want to make sure that we understand 0 exists on a graph and x-intercept does not exist. Alright, so max and mins, if I look at this graph, it is pointed upward. It has a low point, a minimum. So it would be a minimum at the vertex, which is at negative 3, 1. So negative 3, 1. Increasing and decreasing. Again, if you want to sketch your axis of symmetry to kind of break it in half, it's right there through the vertex. And we kind of switch because when our parabola is pointing downward, it increases and then decreases. But when your parabola is pointing upward, starting on the left, it decreases first and then switches to increase. So my increase will be to the right of that axis of symmetry. The axis of symmetry is at -3. So I'm increasing for values x is greater than -3. And my decreasing would be to the left. So that would be x is less than -3. So there was a really quick overview of what we did with graphing quadratics. I hope this helps you review that material. And I'll see you in class.